My name is Zhengchen Zang. I'm a postdoc investigator working with Dr. Rubao Ji at Hui. I started my postdoc research focusing on the northeast US shelf in January 2020 after finishing my PhD study. My research interest is to explore how phytoplankton dynamics respond to the rapid climate change. As a biological modeler, I use a high-resolution 3D biological model to simulate phytoplankton dynamics on the northeast US shelf. The objective of my study is to try to understand what controls the phytoplankton seasonality on the shelf and why the seasonality has very strong spatial heterogeneity. The northeast US shelf is the ideal location to study phytoplankton dynamics due to its high primary production and the strong climate-related variability. Using numeric model, I quantitatively estimate the impact of different factors regulating phytoplankton growth like temperature, nutrient, and light intensity. And I find the growth of phytoplankton is more limited by nutrients in the mid-Atlantic bight, while in the further upstream regions like Gulf of Maine, the phytoplankton growth is more limited by the temperature. The interaction between the nutrient and the temperature cause an early spring bloom and later fall bloom in the mid-Atlantic bight than the Gulf of Maine region. Our model will resolve the seasonal variation of phytoplankton size structure with more small phytoplankton in the warm season and more large phytoplankton in the cold season. The peak of large phytoplankton proportion appears in March and April when spring phytoplankton bloom happens. Compared with field measurements, numeric model can better cover our study region with high spatial and temporal resolution. And the model can better quantify the response of phytoplankton community to different physical and biogeochemical processes, which are difficult to be directly observed in the field. As a modeler, working with other researchers focusing on field observations in the NES LTER project can help me establish a modeling framework to synthesize observational data from different sources and identify the major patterns and drivers of the spatially variable phytoplankton dynamics. Since LTR transect is located at the boundary between the Gulf of Maine and Mid-Atlantic bights, phytoplankton abundance and productivity along the transect can be more sensitive to the interaction between the two shelf ecosystems and climate change. Now I'm applying our biological model to more recent years so we can directly compare our model results with LTR observations. And my future research can provide more insights into the interannual variabilities of phytoplankton's abundance and size structure on the northeast US shelf.